Welcome back to Math Video Tutorials, and thank you for tuning in. In this tutorial I will show you how to answer this equation. We cannot solve the equation in its current form because we have a cos sec theta and a cot theta in the same equation. So we need to use the identity to convert the equation into cos sec theta. So we need to, in the identity, make cot theta the subject. So I'm going to write it down as cot squared x is equal cos sec squared x minus 1. So we can change the x for theta to suit our equation. So we're going to say cot squared theta is equal cos sec squared theta minus 1. What we need to do now is to replace cot squared theta in my equation with this right hand side expression. 2 cos sec theta plus 7 is equal cos sec squared theta minus 1. Since this is an equation to solve, we need to make it equal to 0. So we need to move everything to the left hand side. So I'm going to move cos sec squared theta to the left hand side. It becomes minus cos sec squared theta, and the minus 1, it will become plus. That's plus 1 plus 1, it becomes plus 1, and plus 2 cos sec theta and plus 7 equal to 0. What I have to do now is tidy up and collect the like terms. The only like terms is the number terms. 1 add 7 is 8. So we've got minus cos sec squared theta plus 2 cos sec theta plus 8 is equals 0. I could do it now is change the cos sec squared sign to positive, and to do that we just must multiply by minus 1 the whole equation. So multiply minus cos sec squared theta by minus 1, the 2 cos sec theta by minus 1, and the plus 8 times it by minus 1. So we get our new equation. So cos sec squared theta minus 2 cos sec theta minus 8 equals 0. Now if I was to replace the cos sec theta by x, so cos sec squared theta will become x squared. 2 cos sec theta will become 2x, and 8 stays the same, equals 0. So just to give you an idea, this is the cos sec equation can be factorized in the same way as you would factorize any quadratic expression. So this one, the x expression, will factorize to x minus 4 bracket x plus 2. So x minus 4 bracket x plus 2, because minus 4 times plus 2, that will give us minus 8, and minus 4 add 2, that gives us minus 2. What I have to do now is to replace the x with its original expression, which is the cos sec. So let's write it down. Cos sec theta minus 4 bracket cos sec theta plus 2 is equal to 0. So now we've got an equation in bracket to solve. So we have either the first bracket equals 0, that is cos sec theta minus 4 equals 0, or cos sec theta plus 2 equals 0. This equation will give me cos sec theta is equal to 4. Cos sec theta is equal to 4, and this equation will give me cos sec theta is equal to minus 2. Now what I need to do is to rewrite the cos sec using the regular trig expression, which is in this case 1 over sine theta is equal to 4, and this one same 1 over sine theta is equal to minus 2. So we've got two equations to solve. 1 over sine theta is equal to 4. 1 over sine theta is equal to minus over 2. Again, we need to make a sine theta as a subject. So we need to flip this left-hand side over. And the same thing here, we need to do the reciprocal of 4. Because this is a 4 over 1. And you flip it over, it becomes 1 over 4. So for the first one, let's call them, this is number 1. This is number 2. For the first equation, number 1, I get sine theta is equal 1 over 4. That means the angle theta will be calculated using the inverse sine function. Inverse sine of 1/4. And same thing here. Sine theta is equal minus a half. So therefore, theta is equal inverse sine of minus a half. Now notice that the sine function is positive here. In my cast diagram, I would expect a solution in the first quadrant and the second quadrant for this one here, for number 1, because the sine value is a positive. For number 2, the sign is negative, then I would expect a solution in the quadrant number 3 and quadrant number 4. So therefore, this quadratic trig equation covers all the 4 quadrants. All right, so let's do number 1 first. So we grab our calculator, and assuming that we have our calculator set to degrees because our interval is in degrees. So we'll do the first one, the inverse, that's shift sine 0.25, and that will give us 14.4775, so on. We're going to round it to 1 decimal place. That will be 14.5 degrees. That's 14.5 degrees. I'm going to need to change the equal to approximately, and that is 1 decimal place. And then we do the same thing for the other one. So again, shift sine, this time is negative 0.5. And the answer is negative 30. This is an accurate value there, minus 30 degrees. So for this equation, we have, because the sign is positive, we have one solution in the first quadrant and another solution in the second quadrant. So let's mark them first. That's the one obtained from the calculator. So this is 14.5 degrees. And there will be another one here. Now to obtain this one here, you need, because these two angles are the same, and remember we are following this direction. So the first one is this angle, 14.5 degree. The second solution will be all this. Now if I call it theta 2, now you can see theta 2 is going to be 180 degrees. This is 0, by the way. This is 90, 180 and 270. And then back to 360 for full turn, because 360 is part of our interval. So the second solution for this equation, sine theta equal 1/4, will be theta 2. So it's going to be 180 minus 14.5. As I explained, these two angles are exactly the same. If I shade them, let's write down some of the answers here. Theta, we said, is equal roughly 14.5. And then we have the second one, which is 180 minus 14.5. Let's do the second one for this one, number 2 here, for this one here. This is a negative, so I would expect a solution here. So I would expect a solution here and another one here. Again, this is my, let's put the angles, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then 360 degrees. The same direction we follow, of course. So therefore the first solution will be, the first angle will be, you always measure from the positive part of the x-axis, or from 0, and you go follow the positive direction. So the first solution is going to be this one here, and the second one is going to be all this. Okay. Now if I call this one theta 3, all right. Now we've been given this one here is minus 30 degrees. That's what the calculator gave us, minus 30 degrees, because we have entered a negative value here, minus a half. Now, since our interval is in positive angles, values of angles, so we need to rewrite this one. Instead of minus 30 degree, that is just like saying 30 degree away from completing the full turn. So we write it down as 330 degrees. So let's rewrite that one, 330 degrees. Because if you plug in 330 degrees, if we do that in a calculator, if I do sine 330 degrees, that will give us minus half our value there. Can you see that? So sine 330 or sine minus 30 are exactly the same. So we need to rewrite it according to our interval, which is given in positive value of degrees. All right, so the first angle for this one here, or solution, is 330 degrees. We know this is a 30 degree angle, this one here. And we know this one as also is equal to 30 degrees. So in order to work out theta 3, we need to do 180 plus 30 degrees. So basically theta 3 is equal, let's write it down here, we'll rewrite it. So theta 3 is equal 180 plus 30 degrees. So let's recap on our solutions. For the first equation are these ones. For the second equations are 330 degrees, and 180 plus 30 degrees is 210. I still have to do the calculation here for this one, which is 165.5. Let me just rewrite it. Let's rewrite it to make things neater. 165.5 degrees. So again, so I got all the 4 solutions for each of this equation. Now it's time to rewrite the whole thing as one solution, like just theta equals, starting from the smallest one, 14.5 degrees. Next one is 165.5 degrees, and then 210 degrees, and then finally 330 degrees. These are the solution to our quadratic trig equation here within this interval, of course. One way to check that all your answers are correct is to plug each angle or solution into the calculator. Sine 14.5 should give you something close to a quarter, or 0.25. Sine 165.5, it should give you something close to 0.25. It will not give you exactly 0.25, because remember we have rounded these 2 answers to 1 decimal place here. For these 2, the answers will be accurate. All right. Okay, so that's the end of this tutorial. I hope it was helpful. Thank you for watching, and take care.